Hey boys and girls, so today we're going to be going over lesson 2, which is circles, chords, diameters, and their relationships. All right, so if we start off by looking at the do now, it says in the diagram below, line segment BC is the diameter of circle A. So there's a few important things going on here. They told me that BC is a diameter of circle A. So if I look back at the circle, I can clearly see that this is a diameter because it goes through the center and it hits both sides of the circle. All right, so I know that it's a diameter, and I know it's circle A because whatever the center is labeled, that's what you would label the circle. So I know it's going to be circle A. Point D, I don't see point D, but it's telling me again that it's going to be unique to points B and C. So I know that if it's unique, it can't be where point B or where point C are. So I'm going to go ahead and just label my point D, maybe like right here. All right, so point D is different from B and C. That's really what this is saying. And it's also telling me that it's plotted on the circle, so that's why I'm adding it on. And then it says which statement must always be true. So I'm seeing the triangle symbol here, so I'm going to just look at choice 1 and create that triangle and then go from there. So it's BCD, BCD. So I'm just going to quickly grab my straight edge. Just so happens that I happen to have one of these on me, guys. So if you don't have a ruler at home, just do the best that you can to connect these lines. Okay, so if I look at this triangle BCD that I just formed, well, there's something really important I know we had gone over in lesson 1, and that's if you have a diameter that's a part of a triangle, like right here, this diameter is a part of this triangle, I know that the diameter also is considered a hypotenuse of a right triangle. So I know that this isn't just a diameter in the circle, it's also a hypotenuse in the triangle. All right, so I know that hypotenuses are right across from, you got it, right angles. So I'm gonna mark angle D as being 90 degrees with the box. So if I look at choice 1, it's saying that this triangle is a right triangle. And I know that's absolutely true because we just went over that yesterday in lesson 1. So I know this has to be my answer. But if I look at choice 2, it says that it should be isosceles, which means these legs should be equal. And clearly they are not. CD is tiny and DB is pretty big. So I know it can't be 2. If I look at 3, it says that they're supposed to be similar. Well, you guys learned if 2 triangles are similar, I need at least 2 angles, right, for angle, angle. I only know one of them, so that wasn't enough. And then if I look at choice 4, for me to say that they're congruent, that means that these 2 triangles are exactly the same. I'm not even going to create these because I have no idea how long any of these segments are. So it's not enough information. So it has to be choice 1. And then if I want to answer the question, it says, how do you know it's going to be choice 1? Because line segment BC is a diameter in the circle, right? But if this diameter is also a part of a triangle, like it is right here, it also is considered a hypotenuse. So that's really what I'm going to write. It's a diameter, which makes it a hypotenuse. In that triangle. So it's a hypotenuse in triangle BCD. All right, here we go. So these next 4 vocab words are huge for this entire lesson, and it's going to be huge for the rest of this unit. It's like so important that you guys either make like a Quizlet on this, try to make flashcards on this, even if you can try to just like memorize it from the notes, like whatever you got to do. This is so important. This unit, there's a lot of information that unfortunately just needs to be memorized. And this is, right at the beginning of it. So again, just whatever you got to do to get that information solidified in your brain, get that done. All right. So if I look at this definition, it says if I have a diameter that's bisecting a chord. So diameter is an important vocab word. We know that bisecting means to cut something in half. And a chord is another important vocab word that we had gone over yesterday. So again, it's saying that if a diameter is bisecting a chord. So if I look here, I can see that this diameter is bisecting this chord. because a bisector cuts something in half, right? And this is showing that they're equal. 1 and 1 dash means that they're the same. But I know that it's not just bisecting this chord, it's also forming right angles at the same time, all right? And again, this is something that needs to be memorized. So if two lines make 90-degree angles, you got it, that means they must be perpendicular. All right, so that's going to be our first definition. This is also true for a radius. So I can either have a diameter that's bisecting and forming 90-degree angles, or if I cut off that bottom piece, I could have just a radius that's bisecting and forming 90. All right, so it works for both. Number 2, if a diameter is perpendicular to a chord, so diameter is an important word, so is perpendicular and chord. So again, if I see here that I have a diameter that's perpendicular, forms 90 to a chord, here's my chord, then it's not just making those right angles, it's also bisecting it. So I'm literally taking what we just said in the first bullet, and now we're just switching it. So if they bisect, that means they also make 90. Same thing, if they're making 90, that means they also bisect. It's just using both at the same time. And then just as a review, I know that if this angle is 90, the angle adjacent is 90. Same thing, if this is 90, the angle adjacent, right? So it means all of those guys are 90. And the same thing, it's not just true for a diameter, it's also true for a radius. All right, underneath. It says if two chords are congruent, so I'm just going to highlight that. If two chords are congruent, then the center is equidistant from them. All right, equidistant, right, means the same distance, equal distances. So I know that if this chord is equal to this chord, all right, and I know that's true based on these markings, then I know that the center is the same distance from the chords. The center is the same distance whether I go to the left or to the right. These little guys that I'm forming right here, that center is going to be also equal on both sides. Okay, so I'm just going to highlight this extra piece of information that I just added on because that's really, the definition that we're going over right now. So I would add that to your diagram as well, if you can. I think it's going to help. Okay, and then just like at the top, we said if it was bisecting, it makes 90. If this makes 90, then it's bisecting, right? We just swapped them. So it's the same thing that we're going to do down here. So I know that if two chords are equal, the distance between them is equal. Same thing, if this distance is equal, then I know these chords must be equal. So the two chords must be congruent. All right, and then I'm just going to go ahead and again, I'm just going to highlight the chords because that's really the definition that we're going over here. All right, good? Flipping over to the next page then. Okay. All right, so if we look at example 1, if I just start reading over the directions carefully, it says in circle G, line segment AC is perpendicular to line segment BG. So I know in class we usually circle this and then we'll label, what it represents. I'm not going to do that here on every question. It's just going to take up a lot of time. But if you want to, you can always refresh yourself and just write, that's the perpendicular symbol. All right, we know that perpendicular forms 90. So I know that line segment AC forms 90 degrees with line segment BG. So I'm just going to mark those 90s because again, if this is 90, the adjacent is also 90. Next, I know that DF is also perpendicular with EG. So DF forms 90 with EG. So I'm just going to add those 90s on as well. And then last but not least, it says EF is 12. So I know this little chunk, E to F, is going to be 12. And then the question says determine the length of AC. So if I want to know this whole length from A all the way to C, you always want to label whatever you're looking for with an X, so I'm going to add that to my picture right away. All right, now I got to think back to some key information that we just went over on the last page. So I know that if I have a diameter or a radius that's perpendicular to a chord, it's not just making 90 degrees with the chord, it's also bisecting the chord. Okay, some of you might be thinking, excuse me, teach, that ain't no radius. It absolutely is. I know that it's not drawn in all the way, but you could totally extend this segment to the circle if you needed to. So if that makes you feel better, you should absolutely add that on. But it technically is a radius because it's coming from the center, and I can extend that straight line all the way to the circle if I want. All right, so it's the same thing for GE. I'm just going to go ahead and extend that line segment right to the circle. So again, if I have a radius that makes 90 with a chord, I know that it's also bisecting that chord. Okay, and that comes back to the first and second bullet point on the first page. Okay. Now you guys might be wondering, but how do I know that all 4 of these little chunks, how do I know that they're all exactly the same? That's a great question. This comes to the second 2 bullet points, those 3 and 4. So I know that if the distance from the center to a chord, right, the center to a chord, I know that if that distance is equal, and it is, because it's marked, that means that the chords that it's hitting are equal. So I know however long AC is, DF is the exact same length. All right, so if this is 12, I know this is 12, which means the entire chord is 24. All right, so I know that if this entire chord is 24, I know this entire chord has to be 24. And again, because the center to the chord is equal from this center to this chord, so that means these distances have to be the same as well. All right, this is all from the first page. So how long is line segment AC? Well, if I either break up these numbers, because I know this is 12 and this is 12, that means this little guy is 12 and this little guy is 12. Well, when I put them together, I get 24. Or I could have said, well, I know DF is 24, which means AC is 24. Okay, so however you wanted to get that answer, there was 2 different methods. Either way, the answer is 24. All right, I would, again, if I'm confusing you on any of these questions, or if you feel like you're getting kind of stuck, I would definitely look back at the first page and then maybe rewatch this section again. Okay, moving on to example 2. So it says, given circle A with line segment BC being perpendicular to line segment DE. So just like we said in example 1, this is an important symbol. So in example 2, I'm seeing it again. I'll circle it so I can mark it. So I know that BC is perpendicular to DE. So that means there's 90 all the way around. I know that FA is 6. So F to A, this little chunk is 6. And I know that AC, A to C is 10. I'll add that on. And then I'm looking for 2 different pieces here. So I want to know the length of BF, this little chunk, and then DE, this entire chord. All right. So there's a lot going on here. Before I even look at what they're asking me to solve for, I'm always thinking about a diameter or about a radius, because those help me a ton in circle questions. So I'm looking here and I'm saying to myself, okay, well, I know that A to C is a radius because I'm moving from the center to the edge. So that means that A to B is also a radius because I'm moving from the center to the edge of the circle. So I know if this length is 10, I know this has to also be 10. So how do I get from 6 to 10? Well, I know 6 plus 4 is 10. So how am I getting my answer for BF, this little chunk? Well, line segment BF is 10 minus 6. I'm taking the whole length, which is 10, subtracting away what I know, so I'm left with my answer, which was 4. All right. Now underneath, it's asking me to solve for DE, this entire segment. So now I'm going to think, well, we just went over that AB is a radius. And I know that if I have a radius that makes 90 degrees with a chord, that radius also bisects that chord. Okay? This is from 1 and 2 on the first page, the first 2 bullets. So I know that whatever this length is, this has to be the same thing. So I'm going to give it a variable like A. So I know if this is A, this is also A, because they're exactly the same. And now this is the tricky part that you're going to use a lot of on future questions. Right now it looks like they didn't give you enough to solve the question, and you guys would be right. There's really not enough right now, but I can always add extra information on. So I keep referencing radius, right? So I know that any point, any line segment from the center to the edge is a radius. So I'm just going to create a line segment from the center to the edge of the circle, right? So AC is a radius. AD, I just created that, right? It's also a radius. AB is a radius. I could make another one, right? A to E if I wanted. I'm not going to, but I can. All right, and I know that the length of any of these radii are 10. So I know that the length from A to D is 10. Can anyone tell me what shape I just created? Oh, you absolutely have it. It's a right triangle. So I can see that 6, A, and 10 are all segments of my right triangle. All right, and I know that right across from the 90-degree angle is my hypotenuse. And this is going to help me solve for DE, all right? And you'll see as we go through. So I'm going to write the formula for finding the missing side of a right triangle, which is the Pythagorean theorem, okay? I know that A and 6 are my legs, so A squared and 6 squared. And I know that 10 has to be my hypotenuse because it's across from the 90. So I know that if I take 6 squared and subtract it to the other side, I get 64, right? 100 minus 36, because I move this over, gets me 64. And then if I go ahead and get rid of that square by taking the square root, I get my perfect answer of 8. And this is where they always try to get you on tests, quizzes, and like the Regents. You did all this work and you get your answer of 8 and you think that you're done. You always need to reread the question. So if I look back, I want to know the length of DE. Well, A only represents D to F. I want D to E, this entire piece. So I know that A is 8, right? A is 8. And I need both 8s to get the entire segment, all right? So on the side here, I'm just going to show that 8 plus 8 gets me 16. Which is my final answer. Okay, moving on to example 3. It says in circle B, line segment BE is perpendicular to line segment AC. So I can see that BE makes 90 degrees with AC. So I'm just going to add all of these right angles all the way around. Then if I continue reading, AB is 10. So AB is 10. I'm going to mark that. And I know that AC is 16. A to C is 16. Just because it's getting cut right now, it looks like at least it's getting cut. I'm not going to add the 16. I'm going to come back to that in a quick minute. All right, so let's circle back there. It says determine the length of DE. So DE is my goal. I'm going to throw an X here because this is what I'm trying to solve for. All right. Just like in example 2, if I have a radii that's perpendicular with a chord, it also bisects the chord. So it's the same thing here. If I have a radii that's perpendicular to a chord, it also bisects the chord. all right? So if I know AC is 16, I can break that up for 8 and 8, okay? So I'm just gonna add that to my diagram. If I look again, because now I've added everything that they gave me in the picture, I'm just gonna look for any type of diameters or like a radius that maybe I see, because I know that those help me more than, you know, anything right now. So I know that from the center to the edge is a radius. The center to the edge is a radius. Center to the edge is a radius. So right now I'm seeing 3 radii, and hopefully some of that will help me right now. So I'm also seeing that I have shapes that are already built in for me, like these right triangles, all right? So just like up top, I didn't have a right triangle, so I had to make it. But in example 3, I'm lucky because it's already here for me. So if I make BD, I'm gonna call it the variable A. If I use Pythagorean theorem right now to get the length of this little chunk from B to D, then I can easily get the length of DE, right? Because I know the whole piece has to be, you got it, 10. Because this is 10, this is 10, and this is 10, because they're all radii. Okay, I'm going to start by setting up my Pythagorean theorem, which is a squared plus b squared equals c squared. And again, right now I'm just looking at this one right triangle, so I might even highlight that out just so it's clear as day when I'm going over here. And I know that the hypotenuse is across from the 90, so I know C is 10. So I know if C is 10, then that means A and 8 are my legs. A and 8. Anytime you plug in, don't forget to use parentheses, just like we always do. And then the same thing, if I move this 8 squared over to the 10, I end up getting 36. All right, and then I got to take the square root of both sides to get rid of that exponent too. And then my answer is 6. But again, 6 is not my final answer, guys. 6 is just this little chunk from B to D. All right, I want to know the length of DE. So I'm going to show now that in order for me to get the length of DE, I'm going to take 10, which is the whole segment, subtract away 6, because that's what I don't want, so I'm left with 4, and 4 is what I do want. So I know x was 4. Okay, moving on to the next page. So now if I look here at example 4, let me make sure we're all together. It says given circle A, AF equals AG. All right, that's pretty important. I'm gonna go ahead and mark that right away. So I know A to F is the same length as A to G. All right, we'll come back to that in a minute. And I know that B to C is 22. So I know that B to C is 22. All right, it says determine the length of DE. So DE is my X, because that's what I'm solving for. Now, this question might look challenging. It's actually the easiest question on the entire lesson. So if you guys, again, look back at the first page, I know that if these distances are equal, and they are, I know that these chords are also going to be equal. So I know that if this chord is 22, this chord also has to be 22. Because from the center to the chord, right, if that's equal, then I know the chords themselves are going to be equal. So what's the length of DE? Well, line segment DE is 22. And then last but not least, if we look at example 5, it says in the figure, circle P has a radius of 10. So I'm just going to highlight that keyword to remind myself. I know anytime I see a radius, I feel like that's important. So I know that the radius is 10. So I'm going to mark PE as being 10 because I know that's a radius. And I know that P to D is also going to be 10. Okay, I'm not going to add it right now because it looks like the line segment's getting broken up, but I'll highlight it to remind myself. And then it says that AB is perpendicular to DE. So I know that AB forms 90 with DE. So I'm going to add those 90-degree angles everywhere. If AB is 8, this whole length is 8. I don't like that it's getting cut right now, so I'm going to come back to the 8. It says determine the length of AC. So AC is this little chunk right here. I'm going to throw an X on it because that's my goal. All right. Well, I know, just like in example 2 and example 3, that if I'm a radius, right, and I'm perpendicular to a chord, I don't just make 90 with the chord, I also bisect the chord. So I'm going to mark that. So I know these chunks are equal. Now I'm going to use the 8, because if AB was 8, I know that each piece is 4. And the question asked me for AC. Well, AC had my X, and I just found it. It's 4. And I'm done. So line segment AC is 4. All right. Let's just double check on the back. All right, so the back is going to be your homework. Make sure that you guys actively try to practice some of these questions on your own. Please email if you have questions or concerns. And again, make sure that you are submitting your work each week. Some of you have not submitted any lessons yet, okay? It's important that you are clicking geometry and then clicking assignments every single day to check for those lessons. We just want to make sure you guys are getting the credit where credit is due. All right, so if you're doing these lessons, make sure you're uploading them and sending them to us. All right, have a great day, boys and girls.